2.1 linear and quadratic functions and modeling. All right, number 2. These say to determine which are polynomial functions. For those that are, state the degree and leading coefficient. For those that are not, explain why not. So what makes something a polynomial function, or what would make it not one, I guess, would be a better question.
If it's not a polynomial function, then it only has, I don't know.
Has to do with the exponents. If you have it in your notes, it's probably all the way at the end. Yep, no negative exponents, and what else? There's one other scenario.
And then like square roots.
Yeah, no square roots or fraction exponents. So, number 2, f of x is equal to negative 9 plus 2x. So, is this a polynomial function?
Yes.
Yes, okay, so then I need the degree and the leading coefficient. So what degree is this? 1, okay, so we're looking at the highest powered term, and that would be x to the 1. And so the leading coefficient is 2. Yeah, so this one's a good one because a lot of people will tell me it's negative 9, but it's the number that's on the highest powered term is what we care about. For f of x is equal to 13.
Yes.
Yes. What's the degree?
0.
And leading coefficient?
13.
13.
So we don't need like an x in there somewhere?
No. We just can't have, because like this still graphs a line.
Oh.
We just can't have, we just can't have negative exponents or radical or fraction exponents. 6, f of x is equal to 4x minus 5x squared. Is this polynomial?
Yes.
What's the degree?
2.
Leading coefficient?
Negative 5.
Yep. All right, next. Write an equation for the linear function f satisfying the given conditions. So they give us, in number 8, f of negative 3 is equal to 5, and f of 6 is equal to negative 2. And I want an equation of a line. So what do I have here?
I would think basically we have ordered pairs.
Okay, what are my ordered pairs then?
5, negative 3, and negative 2, 6.
You have them flipped.
Okay. Negative
So
3,
remember,
5.
whatever is f of whatever is always x. So negative 3 is x and 6 is x, and then whatever it's equal to is y. So my two ordered pairs are negative 3, 5, and 6, negative 2. So aside from that, like you've done this before, we're going to find slope, and then we're going to use point slope form, and then we have our equation of our line. So how do I find slope?
y1 minus y2 over x1 minus x2. Or
Yeah.
y2
But
minus y2
flipped, but yes. It doesn't really matter as long as you do it the same for both, because this could be 0.1 and this could be 0.2, or this could be 0.1 and this could be 0.2. So negative 2 minus 5 over 6 minus negative, so plus 3. So negative 7 over 9. Now what's point slope form generically?
Y minus y1 equals m times x minus x1. Virginia, you could have kept on going.
No, you distracted me. And I
We could have said the
I
same
fell
thing.
behind.
All right, so now, does it matter which point I pick?
No.
No. So which one do you want to do?
6, 2, negative.
I was 2.
I was 2.
No, the girls outnumber the guys,
Yes.
so. Alright, so y minus 5 is equal to negative 7 over 9 times x plus 3. This is minus a negative. So then I'm honestly okay if you leave it there. The book is going to take it and, well, I say that. I don't know what they're going to do with it because the answer's right in front of the book. You can either leave it here or you can multiply and move stuff around if you are so inclined. So we would have y equals negative 7 over 9, x minus 7 over 3 plus 15 over 3, because that would be 5 being added over. So that would reduce to negative 7 over 9 x plus 8 over 3. So either of those two forms to write it in would be fine. In calculus, we do a lot more in point-slope form rather than slope-intercept form. So if you want to just be getting used to it, you can. One page of examples down, y'all.
How many pages were there?
3. 12, another one like that. F of negative 4 is equal to 0, and f of 0 is equal to 2. So what are my ordered pairs for this one?
Negative 4, 0, and 0, 2.
So slope 2 minus 0 over 0 minus negative, so plus 4. So that's going to end up being 1/2. Which point are we using in point slope? 0, 2. All right, y minus 2 is equal to 1/2 times x minus 0. So then you can either, well, I wouldn't leave the 0 in there, but you can leave it there. Or y equals 1/2 x plus 2. Now, if you had used the other form, you wouldn't have even had to move something over, or the other one, because y would have been 0, and you would have just had y equals on the left.
I was gonna say we should go with the other one. I don't know why, but like they already picked it up. The second one.
I thought it was gonna be easier.
I know. I didn't see a negative, so I was like, yes.
Silly
Yes.
girls.
Either way, you get the same answer, so it doesn't really matter, but.
One of them just looks better.
All right.
God, you were telling me about me or Riley. Like, why are we just skipping over this?
Why is nobody listening to that?
Well, I mean, if
Yeah, but the people that don't know what's going on would be like, what?
Imagine the people who are gonna be listening to this one in a minute.
Like, okay.
They're going to be like, that boy, he has not learned yet.
What if I pick Victoria?
I don't know, Riley, your new boyfriend might be jealous.
Hey now.
Other Josh. Other Josh.
All right,
Josh Senior?
Yeah.
20. H of x is equal to 1/4 x squared minus 1. These say to describe how to transform the graph into the graph of the given function. So basically, we start with x squared. How do we get here? So what occurs to move this to where it is from x squared?
So we move it down 1 and we.
Yes. 1/4.
Good job, Virginia.
Down 1 and, yes, compressed 1/4. Compressed by 1/4.
So that's just saying like how it's moved.
Yeah.
Okay.
Um, 22. H of x is equal to negative 3x squared plus 2. What's happening with this one?
Up to reflected stretch 3.
Yep. All right, the next ones want the vertex and axis of symmetry of the graphs. What in the? I drew a 2 and then we got an arrow.
It looks like the all real numbers thing that you do.
Yeah.
With like
With
the two little
one.
that thing.
Yeah, that.
The weird R.
Thing had a mind of its own. G of x is equal to -3 times x plus 2 squared minus 1. And so I'm trying to find the vertex and the axis of symmetry. So let me find where that was in your notes. Was it in here? Maybe, maybe not. Yes, it is. So remember the form for this is in vertex form as it is. So remember the form for that is f of x is equal to a times x minus h squared plus k. And the vertex would be at hk. So that means if this sign is negative, then we copy down just h. So it's basically the opposite sign of whatever's in here goes down here, and it's the same sign here for k. And then the axis of symmetry is at x equals h. Remember, the axis of symmetry is a line. So the vertex for this would then be what? -2, -1. So this is always going to be the same sign. This is always going to be the opposite sign.
I think you got those backwards.
Yeah.
I was like looking at it and I was like, yeah, because I don't know what I was looking at. Opposite sign, same sign. And I can't spell either. I promise it says opposite and same. It doesn't look like it. I'm going to fix it.
It's okay, you're a math teacher, not an English teacher.
That's very true.
I'm doing it now, I just did it. I knew what I was doing too.
I know. I was like, I knew it, and I just wrote them backwards. So then my axis of symmetry is where?
I'll let you take this one, Virginia. Specifically you, Virginia.
-1.
What in the world? -2.
I meant
Negative 2.
I meant or 2. It's just
Negative
2, right?
2 people. -2.
X equals -2.
I told
It's
you.
whatever the x value of your vertex is your axis of symmetry.
I feel really stupid now because I was so confident.
Dang. I was like 2.
Maybe I should have let you guys take the next one.
Dang, Josh. Remember all your
The most sassy math man
I
ever.
know.
Then again, it might be entertaining if I do it.
All right. 2 times x minus the square root of 3 squared plus 4.
We got this one, Josh.
Sure you do.
We'll take it from here.
I hope you take it far. Don't come back.
Okay.
That.
Square root of 3.
-4.
No, just 4.
What?
Oh, same time.
Wait, I promised. Oh, never mind. I thought I wrote down.
Square root of 3, 4. So then my axis of symmetry is at?
Where is square root?
Yes.
You did a fun thing for Virginia.
All this ringing a bell.
Yes.
All right, so this is vertex form to basically quote unquote standard form, kind of is how we're looking at it. But now we're going to take it and we're going to be given standard form, and we are going to take it into vertex form. So 32 h of x is equal to -2x squared minus 7x minus 4. And so basically I need to find h and k to be able to put this in the right form. So according to our lovely notes, where are they? There it is. We need to, let's see. Where is it? Did I not manipulate it for you? Did I manipulate what it is for you and tell you what h is equal to and what k is equal to?
So h is equal to negative b over 2a and k is equal to c minus a squared, h squared.
Okay, I did manipulate it. I was like, because in the notes that I have over here, I just have it as like that b is equal to negative 2ah, and I was like, y'all are gonna be confused. Okay.
Yeah, you did it at the end of the notes.
Okay, cool. So h is gonna be equal to negative b over 2a, and k is equal to c minus ah squared. So that means that for h, I have negative, and then with whatever the sign is, that's going to become positive 7 over 2 times a is negative 2. So that's going to end up being negative 7 over 4 for h. And then once I have that, now I can find k. So this is going to be c is negative 4 minus negative 2 times negative 7 over 4 squared. So remember this negative 7 over 4 being squared, it's going to become positive. So that's going to end up being 49 over 16 times 2. So then I've got...
It's a negative 2. Oh,
No, it's not. It's positive.
yeah.
Negative is positive. So this is going to be 49 over 8. So then I'm going to go ahead and convert this to save a step. So multiply by 8. That's going to be negative 32 over 8 plus 49 over 8, which is 17 over 8. So then now, vertex form, we use the same a value that's up here. And so we end up with f of x is equal to negative 2, that's a, times x opposite sign. So plus 7 over 4 squared. Same sign, plus 17 over 8. Because my vertex was at negative 7 over 4 and 17 over 8. So that one kind of is just a work backwards. So make sure you know those formulas for h and k to be able to do those problems if you have that. Do you need to see another one of those, or are we okay with that? Okay. If you get doing them and you get confused, just ask. All right, the last thing, Josh has a leg up on y'all because of stats class.
Yeah, I told you should take the stats.
46. So they labeled the each axis with values, but it really doesn't matter, to be honest. And then they put points on the graph. So there's going to be... And no, it doesn't matter that some of them are different sizes. It just happens. And so they want to know the strength and direction of the linear correlation, okay? So if the points are pretty tight together, we call it strong. If they're spread out, but you can still kind of make out how they're going, we say moderate. And if there's all over the place, we say weak or no association or correlation. It just depends on what's happening. But as far as the direction, it's positive or negative. If it's no correlation, then there's no direction with it because they're just all over the place. And this is dependent on the slope. So basically, if you laid your pencil down in the points, which way is it going, positive or negative? So is this one, first of all, let's do the easy part, positive or negative? Negative. Change this back to a smaller font so it's not huge. So this is going to be negative. And what do we think?
I would say moderate.
Yeah, probably moderate. We go as far as in stats to say moderately strong. The book says it's strong, but I think they're spread out enough to classify it as moderate. So, as long as I can justify why you have what you have, it's fine. All right, one more. 48. And you're welcome to copy the graphs down on your paper if you want, but you don't have to. All right, so what do we think about this one? Yeah, because these are all over the place, I'm going to say no correlation. A week would look something a little bit more like still kind of having a pattern but being really spread out. So like that, you can still kind of make out that it's going in a negative direction, but they're really spread out. And so that's where I would classify it as weak. It's funny because there's literally a problem in the book that looks like this, but they have it flipped and they call it weak, whereas that problem they called strong in the book. So, again, I would say ask me if you answer it and you're like, mine doesn't match with the book, because I can tell you what I would actually call it.
Yeah.
So, all right, any questions about those? Okay, we don't need to do that part of it. I don't know why I had that written there. Oh, that's really big still. All right, your problems are 1 through 9, every other odd. Okay, y'all know what that means, right? Then 19 through 31, every other odd. And then 45 and 47. I may eventually do a scatter plot problem with y'all, but I also might not. It depends. I don't really know that it's that big of a deal for y'all as far as doing that. So, yeah.